But now I can make modifications. What if I wanted to print it 1 per line? I can add that. I can make the program again, rerun it, and type in his name. And now I get it 1 per line. It's a little ugly. Like now it says output S, but that's just an aesthetic bug. I could go in and fix that. But now I have control over the individual characters in his actual name. So that would seem to be progress in some form. But if I now have access to the individual letters, we can kind of come full circle from the very first lecture where we talked about zeros and ones, and then numbers, and then letters, and now in turn words, otherwise known as strings, by way of a topic called typecasting. Types, of course, are the types of variables we've been talking about. Casting means to convert from one to the other. And if you might recall from the first lecture that capital A was the number we know in decimal is 65, and whatever pattern of zeros and ones that is. Capital B is 66, and so forth. So can I see that now for the first time? Well, it turns out I can. Let me go back to the IDE, and let me go ahead and create a new program called ASCII 0.c. And ASCII, again, is just the standard. It's an acronym, American Standard Code for Information Interchange, which maps letters to numbers and numbers to letters. So let me go ahead now and whip up a quick program. Include standardIO.h for printf, int main void, and then let me go here and do the following. You know what? I'm going to just go ahead and print out, let's say, string s gets get string. Let's just ask for someone's name. And then let me go ahead and do the following. For int I gets 0, I is less than the length of that string, learning from last time, I++. So this is going to iterate over the whole string. And now what I want to do is this. Let me go ahead and print out the following. Let me print out the character itself, and then a space, and then how about an integer, and then a new line. And we'll see what this does in just a moment. I want to plug in values for these placeholders. So how do I get at the first character of the name if the string is called s? Yeah, so s bracket I for the ith character. And that's going to plug in literally S, T, E, L if Stelios is the one playing the game. But now I put a comma to plug in a second placeholder. And %i. You know what I'm going to do? I'm going to do int in parentheses s bracket I semicolon. So it looks a little cryptic, but let me just remove this for a moment. This is just the same thing twice. Print the ith character of the name, ith character of the name. But in parentheses, I'm doing what's called typecasting. I'm taking whatever that is, which is a char or character, and I'm saying, parenthetically, make this an int instead. So if it's capital A, it becomes 65. Capital B, it becomes 66, and so forth. And if I now run this program, or compile this program, after preemptively fixing what would have been a mistake by adding the header, make ASCII 0.c. Oops, sorry. Oh, common mistake. Nothing to be done. I'm pretty sure there's something to be done. I need to compile it. What did I do wrong? Yeah, don't put the .c. It's a little counterintuitive, but when you want to make a program, you type the name of the program, not the name of the file. Now oh, damn it. I almost learned from my mistakes. What am I missing now? String.h. All right. Include string.h, save it. OK, so let me make ASCII 0, good, / ASCII 0, and now Stelios, enter. And now we see the ASCII codes, or the numbers that correspond to the letters in his name. They're pretty big numbers. They're in the hundreds now, and that's because they're lowercase. We've previously talked only about capital A, capital B, and so forth. But it turns out that the lowercase letters also have values associated with them, like some of those here as well. And now it turns out, now that I know this, now I can kind of do like some low-level stuff that we all take for granted on our phones and websites, like when you just type in your name in all lowercase and the website just fixes it. Or if you type in your phone number in with parentheses, without parentheses, with dashes, without, the website just kind of fixes it and cleans it up into some cleaner format. We now have kind of the low-level control to do this. I won't type this one out manually just because it's a little longer. Let me go ahead and open it up. Among today's examples, in source 2, which is on the course's website, is this example here, capitalize 0. So let me make a little more room for this. It's a little longer, but let's just focus on just a couple lines at a time. Here's the beginning of my program main. Here's a line of code where get string before. I just said, give me the before string. And then I claim, now print the string after, making some changes to it. So what am I going to do? On line 11, I seem to have used the same idea as a moment ago, but with one change, actually. I've done something a little different. Line 11 is very similar to what I've been doing to iterate over the characters in a string. But I did something different, which is what? What looks different now versus what was on the screen a little bit ago? Anyone a little farther back? Yeah. Yeah, it looks like I'm declaring two variables all in like the same breath, so to speak. I have my int I equals 0, and we've done this a bunch of times. But then I have a comma here for the very first time, n equals strlen of s. But if you think about what these building blocks are, OK, the comma is new, but n is on the left, so that's a variable apparently. It's probably an int because the word int came before. Equal sign is assignment from right to left. Strlen is a function that returns the length of a string. So this would seem to be storing, just to be clear, what number in n? Yeah, the number of characters in whatever the string is the user typed in, Stelios or David or whatever the name is. So then I have my condition. Then there's the semicolon, which we have seen. And then there's plus plus. So I claim that this is, in a sense, better design. It's a little more complicated. Like I typed out more characters. I added another variable. But why might it be smart and good design to have used an extra variable, using a little more space to keep a number around, so as to then simply compare I against n? Like, why did I jump through these hoops? What do you think?
Because then it doesn't have to check what n is each time it goes through the loop.
Exactly. It doesn't have to check what the length of the string is on every iteration, because after all, once I or Stelios or whoever types in their name, it's not going to change. It is DAVID or Stelios' name or Maria's name or whoever is playing the game. And so why would you keep calling a function saying, oh, by the way, what's the length? By the way, what's the length? What's the length? Just remember it the first time, because odds are it takes a little bit of time to do that computation and actually figure out the length. And so here, we've simply kept that answer around in n and can compare two variables. Meanwhile, here's a pretty big if-else construct. But if we break it down into pieces, it's doing something relatively simple. On line 13, I am asking the question, if the ith character of s is greater than or equal to a lowercase a, ampersand, ampersand, which we haven't seen before. This means logically and. So if it's greater than or equal to a and less than or equal to z, put another way, if it's between a and z inclusive, in lowercase, what am I doing on line 15? Which is super weird looking. I'm first printing out %c, which is my placeholder, but then I'm printing out the result of s bracket I minus whatever lowercase a minus capital A is. I mean, this is just strange now, but let me just point out one clue. Turns out there's a pattern here, and humans did this deliberately. If you can do the arithmetic quickly, how far apart is lowercase a from capital A? It's 32, right? And you can just do the math, like 97 minus 65. Oh, 32. How about capital B versus lowercase b? It's 32. 32, it follows this pattern. So this is to say, and it's sort of proof by example, like we're not even seeing all the way to z, but trust me, 32 is invariant across all of the letters of the alphabet. They're always 32 away. And I could hard code 32, but that feels a little inelegant. Why don't I instead just arithmetically say whatever the difference is between lowercase a and capital A, and that's all I'm saying in parentheses here. Whatever that numeric difference is in the computer's representation of my numbers, just subtract that difference from the ith character. Now what's nice is I kind of sort of should do this first. Like I should cast the character to an int, but I don't need to be so explicit. Like the computer knows that characters are integers, and the computer knows that integers are characters. There's this equivalence. I don't need to be so verbose as to even say that. It just suffices to let the computer figure it out implicitly that in this context, I'm doing arithmetic on numbers, and then in the context of printf, I'm displaying that number as characters. Like nothing is happening. You're just telling the compiler what context in which to treat these values, numeric or characters. So long story short, what does the effect of these 4 lines of code have on the characters in the user's input? What does it do? It capitalizes it, right? It capitalizes it, and that might have been implied too by the file name in full disclosure, but it's how you think about solving the problem of capitalization. Here's the string, home in on the individual characters, figure out if they're within a range you want to deal with, and if so, do some kind of mutation of them to change from one value to another. I could have done this a horrible way. I could have had like an if, else, if, else, if, else. I could have like 26 conditions checking is the character A. Is it B? Is it C? And if so, make it capital A, capital B, capital C. But that code would have been like this big or bigger. This is now a more algorithmic way of solving the same problem. And if it's not a lowercase letter between A and Z, just print it out. Like there's no work to be done. Now, just so you've seen it, it doesn't have to even be as verbose as this. In capitalize 1.c, which is available also on the course's website, I've made my code a little better designed. I'm now not reinventing as many wheels. I'm standing on the shoulders of smart programmers before me. And I've clearly changed at least one thing. Instead of doing this manual process of comparing against lowercase a and capital and lowercase z, I'm just punting and using a function, which beautifully is called isLower, which just literally answers that question. Because another data type in C is not just int and char and float and string in CS50's library, but there's also something called a Boolean. A Boolean, also named after bool, is similar in spirit to a Boolean expression, true or false, but a Boolean variable is literally just the idea true or false. And so isLower you can think of as returning a Boolean value. It returns true or false, yes or no. And the name of this function, therefore, is very appropriate. isLower, that's a yes, no, or a true, false question. I don't know how it's implemented. If I really care, I could go to CS50 reference, or I could use the man command on the IDE, and I could actually check how this thing works. But I do need one takeaway. To use this, I need to use the C-type library. So there's other libraries that we're now just scratching the surface of, and you would only know they exist by reading documentation like that. But you know what? I can go even further. You know what? If some human years ago wrote a function to check if something is lower, what did he or she probably do as well for me? Yeah, is upper. Also, it does exist. Yeah, so spoiler here. So is upper exists. But if they checked if it's lower or is it upper, I'm going to just go on a limb. ToUpper? Yeah. So it turns out there's a function called ToUpper that converts a letter to uppercase. And indeed, I can now leverage this in my third version of this program as follows. Capitalize 2.c gets even better designed still, if you will. It's even shorter, fewer lines of code, easier to read, fewer opportunities for bugs. How do I solve it now? I still iterate over each of the characters, but I just blindly call ToUpper on every character, because I read the documentation. If you pass a character to ToUpper that is already uppercase, it just prints it out. It doesn't change it. If you pass in a punctuation symbol, it just passes it through. But if you pass in a lowercase letter, it capitalizes it for you. And so I can now kind of I can lean on whoever implemented that before me. It could have been me. I could have wrote my own function called ToUpper, but I don't need to. Because in the world of programming, there exist libraries of code that other people have written for us that we can leverage. Any questions then on that? Yeah?
So this method, you wouldn't be able to capitalize the first letter. It would be all of them.
This would be all of them, yes. So if I only wanted to capitalize Stelios's the first letter of his name, I probably wouldn't want the loop. I would probably just want to capitalize bracket 0 specifically of the letters, but I'd want to make sure that his name is at least one character long, lest he just have hit like enter accidentally or maliciously. Absolutely. So let's just dive in to one other detail here as follows. Suppose that I want to actually know what the length of a string is. I know that there exists this function called strlen, but it turns out I can figure out lengths of strings for myself too. Let me go ahead and write a program called strlen itself, but I'm not allowed in this example to use string length. I'm going to go ahead and include the CS50 library. Let me include standard.io.h. Let me go ahead and do int main void. And now let me go ahead here and do string, bad style, string s gets get string name. And now let me go ahead and do int n equals 0. Just give me a variable, call it n, set it equal to 0. And then let me go ahead and while I'm not at the end of the string, also not valid code, n++. I can use that ++ trick that we've seen before for I++. And then I'm going to go ahead and print out whatever the value of that counter is, because I want in my loop to just count the number of characters in Stelios's name, or whoever's name actually ran the program. And just to be clear, this is what's called syntactic sugar, which is a very sexy way of just saying this is shorthand notation for doing this, which is just boring looking. This does the exact same thing. It's just a more succinct way of doing it. And you'll see little features of languages like this just to save us humans keystrokes. This, of course, is not a solution to a problem.